Well, hello guys, in this video I will try to cover the comparison test, but before going to the main questions, I want to cover two example on comparison test. Basically, they are not the example, they are the kind of part of comparison test. Like, let's say 0 to infinity e to the power minus px dx. So we have to check the convergence or divergence, it depends. So we have to prove something. So first of all, the convergency will occur with a condition and divergency will also occur with a condition in that case. First, this is b, limit b is tending to infinity, as I have told you at the first video, or you can say at the second video also. This is e to the power minus px dx. Now basically you can see limit b is tending to infinity. This is nothing but e to the power minus px with a minus p 0 to b. Now this is limit b is tending to infinity e to the power minus p into b minus e to the power 0, which is 1. Now I am breaking the limit. This is nothing but e to the power minus p by b by minus p with a negative symbol. Well, this is plus 1 by p. Now we have to deal with this. We have to deal with that, not that. So basically, if we are dealing with that, specifically if we are saying something that we have to find out the limit because p is constant. Now you can see here this limit will have three values. First 0, second 1, and third infinity. Now if this limit will be becoming infinity, then the whole integral will not diverge, and if the limit will be becoming 0, the whole integral will converge. Simple. So when it will infinity? When p is less than 0. If p is less than 0, let's say minus 2, then e to the power minus of minus 2 into b, which is e to the power 2b. Now this is a positive number, and also this is nothing but e to the power infinity because b is tending to infinity, and e to the power infinity means infinity. So that is the condition for infinity. Or you can say when p less than 0, then diverges. The integral I diverges basically. What about 0? When p is greater than 0, like let's say p is 2, so e to the power minus 2b, which is e to the power 2b, which is basically 1 by infinity, and which is 0. So we can say when p is greater than 0, then I converges. What about equals to 1? When it will be equal to 1, then nothing will happen. Basically it will be becoming 1 by minus 1 by p plus 1 by p, which is basically 0, right? If it is 1, then this will happen. Now when it will be 1? When p is equals to 0. When p is equals to 0, then we will get 0, and definitely if we will get 0, then we can say when p is equals to 0, then I converges again, right? Converges again. Hopefully spelling is very bad. Jokes apart. Now basically you can see when p less than 0, then divergence occur, and when p is greater than equals to 0, then it's okay, I will converge. Simple. Hopefully you can understand this question. This is a part of comparison test, not the full comparison test. I am just talking about maybe sometime you have to prove that with the you have to prove the condition for divergence and prove the condition of convergence also for a particular question. Let's talk about another example where you have to deal with that kind of question. Let's see the next question. Let's move on to the next page. Well, in that question we have to deal with this dx by x to the power p, and x to the power p, or you can say 1 by x to the power p, not equals to infinity or minus infinity. Okay, now basically you can say and obviously definitely a greater than 0 file. Now limit b is tending to infinity, a to capital B, this is dx by x to the power p. Now this is nothing but x to the power p plus 1 by minus p plus 1 with a limit b is tending to infinity. Well, you can see minus 1 is a constant. We have to solve this limit b is tending to infinity, and function is like what is that, b to the power minus p plus 1 minus a to the power minus p plus 1. Now basically we have to deal with specifically with that, not with that because this is constant. So you have to deal with limit b to the power minus p plus 1 plus a to the power minus p plus 1 by p plus 1. Sorry for a mistake. Right. So basically you have to solve this, which is basically nothing but limit b is tending to infinity, b to the power 1 minus p. Now this limit has three values. First of all infinity, then 0, then 1. When it will 1? When 1 minus p equals to 0. When 1 minus p is equals to 0, then b to the power 0, which is 1. So basically p is equals to 1. And if p is 1, then we will get the integration is nothing but this is minus p plus 1, or you can say 1 minus p. This will be, this limit will be 1. So this minus 1 minus p and a to the power 1 minus p. Hopefully this is visible. And this is for limit is equals to 1. Now what about 0? If 1 minus p is less than 0, then it will be 0. Let's say that means p is greater than 1. Sorry for a moment. Now it is visible. P is greater than 1. Let's say we are taking p equals to 3. So b to the power 1 minus 3 is b to the power minus 2, which is 1 by b square, which is 1 by infinity, which is 0. Now it is proper to you. Now what about infinity? If 1 minus p is greater than 0, that means p less than 1. Now the limit, if the limit is equals to infinity, then the integral will not converge. Basically the integral diverges in that case. But for this and this, the integral will converge. So if p is less than 1, then divergency occurs. And if p is greater than 1, like in that case where we are talking about 0, if it is 0, then this limit will be 0. So we have to deal with that only. So the answer will be like a to the power 1 minus p by p minus 1, because there is a minus, so 1 minus p will be becoming p minus 1. So in that case it's also converging. What about p is equals to 1? If p is equals to 1, we can say p is equals to 1, that means minus 1 plus 1, and this is will be like 1 by 0 into this is what? This is what? P is 1, right? So this is p is 1, then this is 1. The limit is 1, right? The limit is 1. You can see here, if p is 1, then the limit is 1. So this is something like that integral. The integral will be that, but as p is 1, so we can't say that this is existing, because if p is 1, then this is 1 by 0, and this is also 1 by 0, and 1 by 0 is infinity. So Basically, when p is equals to 0, sorry, p is equals to 1, then also divergence occurs. Also diverge basically. So we can say when p greater than 1, then I will exist. And when p is less than equals to 1, then I will not exist. Okay, fine. It's very easy to understand, hopefully. Now I will going to the main questions where we have to deal with the comparison test. Hopefully these two questions are clear to you. Let's move on to the next page. Well, in comparison test, you have to choose a neighborhood function. Like let's say fx is equals to 1 by 1 plus x cube. We have to choose a neighborhood function which is 1 by x cube. It is neighborhood function of fx. If gx will exist, I mean integration of gx will exist, be careful, then integration of fx will also exist. Fine. And if g will not exist, then fx will not exist. Simple. You can understand. Now we are going towards the questions. Let's say this is the question: 0 to infinity dx by e to the power x plus 1. Well, we have to choose a neighborhood function. Let's say you can see in multiple cases you will see something like 1 plus p to the power, I mean px, like 1 plus any kind of polynomial or any kind of any other function. Then you just have to write it like 1 by px or 1 by trigonometric function, let's say. So you can understand, right? In that case, exponential plus 1. So we will deal with this function where gx is nothing but the neighborhood function e to the power x or something like that. Now I have to do same integration dx by e to the power x. And if, let's say this is ig, if this integral will exist, then if will also exist. So e to the power x, I mean 1 by e to the power x means e to the power minus x with a negative sign, 0 to infinity. But wait a moment, we can't solve this using the basic integration method. We have to use the definition, right? So this is minus, this is e to the power minus b plus e to the power 0, which is 1, with a limit b is tending to infinity. Now if you are putting b equals to infinity, then it is basically 1 by infinity, which is 0 plus 1, it is 1. The answer is 1. No, the answer is not 1. Basically we are talking about gx. As ig exists, that means fx, I mean if will also exist. Hopefully you can understand the comparison test. Now let's talk about another example so that you can relate to the question also. Let's say this is dx, this is 1 by 1 plus x cube, 0 to infinity. We have to choose, like fx is equals to 1 by 1 plus x cube. We have to choose a neighborhood function, which is basically nothing but 1 by x cube. So we have to integrate 1 by x cube with 0 to b, well limit b is tending to infinity. You have to use the definition also, okay? I mean you can understand. So basically this is x to the power minus 2 by minus 2, 0 to b with a limit b is tending to infinity. This is let's say b to the power minus 2 by 2 with a negative symbol plus 0, basically limit b is tending to infinity. Now this is 0. Why? Because this is basically b to the power minus 2, which is 2 by b square, and if we are putting infinity at b, then it will be becoming 0. 1 by infinity, I mean minus 0, and minus 0 is 0. However, hopefully you can understand this question also. Let's move on to the next question where we have to deal with this kind of function like dx by log x. Let's say that because log 1 is 0, so we have to take 2 to infinity. You can take 0 to infinity, but in that case you have to break the limit into 0 to 2, then 2 to infinity. And for the 0 to 2, you have to deal with the type 2 where the function is not bounded. So we are not making it complex, just make it simple. So 2 to infinity, like in that case you have to take a neighborhood function where fx is equals to 1 by log x. What about the neighborhood function? So for understanding the neighborhood function, be careful about the graph. Sometimes we need to draw the graph, we need to plot the graph. This is the log x and this is y equals to x, right? But sorry for a mistake, basically the graph will be exponential graph, like not exponential, like the graph is, this is y equals to x and this is the graph of log x. So this is the graph of x, so you can say log x is greater than x, so 1 by log x is sorry for a mistake, I guess I had done a mistake again. Basically the graph is something like that and both will intersect each other at x equals to log x. That means e to the power x equals to x. Well, so they will not intersect each other. Now as you can say that log x is less than x, so 1 by log x is greater than 1 by x. Now maybe it is confusing to you that why we are taking 1 by x, we can take 1 by x squared also. So I haven't any kind of explanation, just you need to take a neighborhood function, whatever it is doesn't matter actually, you just need to take a neighborhood function. Be careful about that, you just need to take a neighborhood function. Oh, now it is visible. You just have to take a neighborhood function so that you can solve the question. So in that case 2 to infinity dx by x, this is nothing but, I mean integration is ln x with the limit b is tending to infinity 2 to b, this is ln b by 2. Now you can see this is infinity, like ln infinity by 2 is ln infinity and ln infinity is infinity. So the answer is basically like the integration is not converging and answer is the integration is diverging. Now let's talk about another example where we have to deal with this 0 to infinity dx. In that case we can see 0 to infinity, that means cos x will be from 1 to minus 1, right? Doesn't matter whatever the limit is. So you can replace cos x as x. Not we are replacing, basically we are taking gx as this, because cos x is very very small, we can say, according to this. So you can replace, I mean we can't replace, basically we are taking gx as something like that. So we have to integrate this 0 to b, limit b is tending to infinity, and basically this is tan inverse b minus tan inverse 0, which is 0. So limit b is tending to infinity, so this is pi by 2. Answer, this is the answer of gx, integration of gx. Okay, I mean this is the answer of ig, and as ig is existing, so we can say if will also exist. So this is all about this video. Now in the next video we will talk about the limit test, and this is the comparison test, and for more better experience you need to practice some questions about comparison test. And thanks for watching my videos. This is all about this video, and goodbye. Thank you.